Hey everybody, welcome back again to Ixxat Connect. My name is Emilio, and in this new episode, CAN market expert Sri Harshavege will give you a detailed step-by-step explanation on accessing battery data remotely. After this session, you'll be able to gain valuable insights into the health and performance of your battery system from anywhere at any time. You'll be able to make data-driven decisions for preventive maintenance and ensure the longevity of your batteries, improve the operational efficiency, and reduce costs associated with battery failures. Whether you're managing industrial battery banks, electric vehicle fleets, or large-scale energy storage systems, this video is your guide to unlocking the power of CAN Fieldbus to cloud technology for remote battery monitoring. So, let's begin. Shri, could you give us an overview of the current market trends?
Absolutely, Emilio. Thank you for having me here. So as you mentioned that there are different levels of batteries systems and battery installations. For example, there's electrification of vehicles, there's large-scale energy storage systems in order for grid stabilization, and we see that the demand for the batteries is skyrocketing in the last years. And one of the most interesting trend in this space is how do you manage your remote assets? So the cloud technology not only provides the real-time data access, but it also gives you insights into critical parameters such as voltage, temperature, current, and allows you to do comprehensive monitoring from far, which is pivotal for today's distributed energy systems.
Yeah, that sounds incredibly efficient. Now, why is the CAN bus considered so advantageous for communication within these systems?
That's a good question. CAN bus is a robust and reliable protocol, extensively used in industrial and automotive applications. The main strength of CAN bus lies in the data transfer capabilities and also fault tolerance, which are crucial for, on one side, the network communication among multiple devices. On the other side, also to ensure that there's safe and efficient operation of information. This ensures safe and efficient operation of batteries, crucial for any system's reliability. The other alternative to CAN in the battery space is the Modbus protocol, and we see that Modbus is being adapted by many upcoming organizations in the battery space. But where we observe a clear differentiation is that these Modbus protocols are mostly suitable for small-scale applications installations, because Modbus usually has a polling mechanism, and when you talk about large-scale battery installations, there's CAN bus is your go-to technology.
Interesting. So, despite all of these advantages, what are the sort of challenges that companies face when implementing these kind of systems?
One of the main hurdles is the limitation of the typical battery management system, also called as BMS. They focus primarily on the safety and operation in real time, and they often lack capabilities of detailed data logging and analysis. So the limitation can hinder in-depth diagnostics and maintenance, which are essential for optimizing performance and extending the lifespan of the batteries.
Yeah, that's quite a challenge. So in terms of real-time data processing, how does the BMS, or in other words, battery management system, stack up?
So unfortunately, most BMS systems are designed to handle real-time data effectively. They ensure safety and performance, but they lack in detecting anomalies or also different kind of patterns within the battery, and which could indicate that there are potential issues with the battery. This lack of detailed data and the slow response can be a significant drawback.
So let's get this more concretely. Which different steps are needed to bring the CAN data to the cloud?
So when we are talking about the CAN data, there are different steps involved that need to be done to get this up. Let me break down this for you. So on one side, we have the BMS system, which is collecting all the CAN data from the battery's modules, such as voltage, temperature, current. And based on this information that the BMS is collecting, it is calculating the state of charge, state of health, parameters such as this. This data is gathered in periodic intervals from the battery modules, which is defined by different manufacturers in different intervals or different sampling rates. And in the next step, the data, the information from the BMS system is being packaged into CAN frames, where there's CAN ID, CAN data length code, and the actual data payload, all such information. Once the data is packaged into CAN frames, it is transmitted over the CAN bus, which serves as the communication network linking various devices. The physical layer standard defines how signals are transmitted along the bus, and the bus arbitration ensures all the devices connected to the bus can communicate without conflicts. In the next step, so now we have the CAN data, we have the CAN frames, we have the CAN bus, which is the medium for transmission. This data is being transmitted to the CAN gateway. The gateway, it has different kind of filter settings to sift through the traffic on the CAN bus and selecting the relevant battery data for further processing. Mechanisms like error handling and managing issues like CRC errors on the CAN bus, all this is being taken care of from the gateway side so that there's a smooth data transmission.
So interesting. What are the next steps?
In the next step, the CAN gateway receives the data and processes them and identifies patterns or mechanisms such as overheating or over voltage. This is done by event detection when specific thresholds are breached. And for the threshold values, each manufacturer has different chemical compositions for the battery modules. And based on these chemical compositions, they define what are the nominal operating parameters. And you can give all this information to your gateway, so the gateway understands whenever there's an anomaly, and these events are then logged for future reference or immediate action, allowing real-time monitoring of the system's health. In the next step, the data is being transferred either to a local storage device or is being transferred via IP-based protocols into cloud. And for this, there are two different elements of it. One is when you can either store the data in your device locally and transmit them only event-based or specific information into your cloud, or you have your data that is being streamed directly into the cloud. The important element here is that the data is being transferred via secure channels. Once received by the cloud, the data is stored in databases, and here redundancy and backup strategies are implemented to prevent that the data is lost and to also ensure that the data is available at all times. In the next step, the data is being processed and analyzed in order to extract meaningful insights, such as tracking battery health, predicting maintenance needs, and in the last step, the data is visualized in dashboards, graphs, and reports, so the users can interpret and understand the data and act based on the data. These visualizations are accessible through the web-based technologies and applications on your mobile phones, on your computers, ensuring that users can monitor the systems from anywhere. Here as well, secure access protocols and user authentications make sure that the data is being accessed or is available only to the right group of people. This series of steps ensure a smooth and secure flow of data from the CAN network to the cloud, where it can be stored, processed, analyzed, and visualized effectively.
Thank you. That was impressively detailed. So, that was the theory. Let's move on to the practical solutions. What are the innovative approaches for these challenges?
The key is advanced data logging integrated with the cloud technologies. By collecting broader data sets, we can gain deeper insights and identify the potential issues early on, allowing for immediate response or corrective actions in order to avoid any larger damage. This proactive approach significantly enhances the battery management, and also on the other side avoids any kind of risks based on the batteries themselves.
So, could you give us an example of these solutions that are applied in real-world scenarios?
For sure. In general, there are two areas in which the battery data is a crucial part. On one side, we have the fixed systems, and on the other side, you have the mobile systems. The fixed systems are examples such as the battery energy storage systems or microgrids with gensets where you have power generators and batteries where it's stabilizing the grid. In these systems, there are three different key value drivers. The first is the battery performance. These insights make you understand any performance losses and reliability issues. The second is the battery degradation. So you understand how your battery is behaving over a period of time and gives you profound information to make a proper decision on trade-off between the costs versus benefits. And the third value driver is the risk aversion. So with it, you can detect any potential malfunctions in the batteries to take immediate action on. And this information is crucial for developers and operators, on the other hand, to fulfill the purpose of energy storage system in the grid and generating revenue. On the other hand, to perform predictive maintenance in order to avoid any accidents or fire risks. That was about the fixed systems, and now the other side, we talk about the mobile systems. Here we are talking about vehicles and machines that move frequently and have either electric powertrains alone or they have hydrogen fuel cells and the batteries as a supporting element to it. In both cases, batteries are crucial elements for them. While the information in fixed systems is also important for these mobile systems, there are more elements that add into factor. To make it clear, let us take electrification within the heavy-duty vehicles. By integrating the vehicle data along with the battery data, we can monitor things like power delivery and energy consumption efficiently. For example, logging the battery data alongside vehicle and the GPS information helps manufacturers understand how the vehicle is performing under regenerative braking. The vehicle manufacturers, they understand how functions such as the regenerative braking works and also understand how batteries perform in different scenarios, based on which they set up the ECUs and program them that they work in their optimal parameters. This information is also later typically used by a fleet operator who uses, based on these informations, how can he charge his vehicle based on the route. So you don't want to have a full charge when you're on top of the hill, because then you would have the regenerative braking. So things like these are better managed when you have more data insights.
So what about the integrity of the data transmission from the battery?
So batteries, they transmit vital information over CAN, such as temperature, voltage, state of health. And each manufacturer, they might use different standards for the CAN messages, but with the right configuration on the data acquisition device, we can ensure that this data is accurately interpreted and also securely transmitted to the cloud. It's also important to keep in mind the way the data is required, which varies between different vendors and applications. The devices for such applications should support both wildcard logging, which is logging all the information that you're receiving on the CAN bus, and also trigger-based logging, where you're specifically defining what kind of data you want to log and define what kind of triggers are to be used in order to start the logging function operation itself. The information being saved can be transported in different formats from the gateways, such as XML, comma-separated values, the CSV, or from the application that we have spoken earlier, like the heavy-duty vehicles. There's formats typically used in vehicles such as BLF, MDF4, and many more.
Fascinating. So, for someone looking to start with advanced logging solutions, what would you suggest?
You need to look for devices that offer flexible configuration options. So the flexibility And the configuration should also be easy to use for the people who are operating it. This allows for, on one hand, the dynamic adjustments that can be done on the vehicles or on the devices, and on the other side also speeds up your development cycles, which helps bringing high quality products into market at a faster pace. Also, how the logging is done and what kind of data is being logged and sent to the cloud reduces the data load on your cloud systems.
So, to wrap things up, what are your final thoughts on the overall impact of these technologies?
Embracing advanced data technologies not only aids in making informed decisions, but also supports the predictive maintenance and ensures the longevity of the batteries. Integrating CAN with the cloud technologies, it's not just a trend. We see that it's a fundamental shift towards sustainable future in energy management and also in the automotive industry. Additionally, one other factor that we have to keep in mind is the total cost of ownership, because this is something that is often ignored in the initial point, because to have a continuity of the solution in different phases of equipment and the effort to set up and configure the devices are something that has to be considered when choosing a solution.
Thank you, Shri, for sharing your thoughts and your expertise today. And thank you to our listeners for tuning in. We hope you found this discussion enlightening and that it sparks further interest in the possibilities of advanced battery management technologies. Have a nice day.